Denis, you just published a book called Just Use Postgres, and my first question is why? Why did you do that? Tell me everything you can about it.
So this is my contribution to Postgres. Postgres played, I think, a significant role in my personal professional career. That was the very first relational database which I started using when I graduated from a university. I was a backend developer, Java developer. And when I graduated, MySQL was the number one database. Everyone used MySQL. We had that LAMP stack those days. It's like Linux, Apache, MySQL, and PHP. But
what year was this roughly?
So that was in 2009, I think. 2009, 2008. Yeah, quite long time ago. And eventually, I joined a company. We were building a high-performance social network. That was the time when Facebook was really popular, and many companies wanted to create their own version of Facebook. So I worked for that company. And our DBAs, our IT teams, they just were super crazy. They said, like, look, no, we have this Postgres thing here. We want you guys to use Postgres. And everybody was questioning them, like, why would you use Postgres? Let's use MySQL, like, because everyone uses MySQL. But we trusted Postgres, and Postgres has never let me down since. Even like that very first project, which I was paid for after the graduation, we were running Postgres in a sharded configuration. It was not a single node. It was a multi-writer configuration. We did not have any extensions in the Postgres ecosystem those days. It was an application level sharding. But generally, since that time, Postgres eventually became my default database whenever I would need to build some web application or whatsoever. And lately, how does it go to the book? The long story short. So that was the very first database which I used. But in the university, when we were studying relational databases or databases in general, we used Oracle because our professor, he liked Oracle, and he had some free licenses which was possible to use. And then let's say eventually what happened several years ago, I joined Yugabyte. I worked for Yugabyte. It's a distributed PostgreSQL company for those who have not heard about them. And one of the reasons why I joined them, because they let me and they promised me that as part of my day-to-day work, I will be able to spend a lot of the time just researching and talking and speaking about vanilla Postgres, just about that open source version. And that was a huge advantage for me. And when I joined them, I started looking into Postgres like day-to-day, and I discovered that I barely knew this database. Because I considered myself as the one who knows Postgres, who used Postgres in production, but I knew only its relational part, like how to do joins, transactions. I knew that JSON exists, but I've never used it. Yeah. But then I started looking deeper and deeper, and I explored this whole ecosystem of extensions. Then I learned that apart from the typical SQL capabilities, now we have modern SQL, like window functions or common table expressions. The database evolved. And what happened next, because I was on the developer relations team, so I traveled a lot. And I had many conversations with the people. And when someone would stop by and ask about Postgres, and I would say like, yeah, Postgres does this, he says like, no, you're kidding. And I'm like, no, that's true. And I discovered that that I was not the only one. There are many people who are yet to rediscover what Postgres is capable of. And there was no single resource. Eventually, I wanted to contribute to Postgres by creating a single resource in the form of the book, where at least you can just study about the modern Postgres capabilities, not about Postgres that evolved into a general purpose database. And so this is the reason. This is the contribution, and this is a long history of why.
That's awesome. Can you roughly tell me what year you kind of had these conversations and decided it would be good to share, like maybe write a book or share some resource for the community?
I mean, it was when it took me a year and a half to write this book from scratch and publish it.
Yeah.
I started, so when we published it in November 2025. I started writing it in just July 2024. So eventually, yeah, it literally was just written 1.5 years in work. In general, the idea, I started, sketching some notes. I started writing some table of content, probably after spending a year in Yugabyte. It was probably 2023 when I started thinking that, no, I need to do something. I was thinking about probably a YouTube tutorial, but we have Aaron Francis, and he does exceptional database courses. And then eventually I thought, okay, it's still going to be some sort of video, some online tutorial, so probably a book. And what happened next? Also, like when around 2023, 2022, we had this AI. Do you remember when this ChatGPT was published? When was it?
Yeah, that was I think late 22.
22, yeah.
Maybe
22.
very early 23, like January.
Yeah, 22, 23. And generally, everyone started looking into AI, and I started looking into how to use Postgres with AI, how to, let's say, create. And back in the days, I don't know if OpenAI still has this marketplace in their ChatGPT website where you can create your custom agent or plugins and let them do something. That was before MCP servers. That was before all those agents. That was the very early stage, 2023 probably, 2024.
Okay.
And I created a nice tech talk. I published it to several conferences. I spoke at many conferences. The idea was how to use Postgres and OpenAI to create plugins for the ChatGPT website. It was really fun. And then eventually, Jonathan Genick, he is one of the acquisition editors of Manning. He sends me an email. He says, "Hey, Denis, look, I just stumbled upon this website that was a Postgres conference in Silicon Valley. And I see that you would be speaking on this topic, like about this, OpenAI, marketplaces, Postgres, blah, blah, blah. Do you want to write a book about those, like how to write plugins for OpenAI?" And I'm telling, "Hey, Jonathan, let's have a conversation." So,
got it.
As a result, yeah.
But
As a result, we go to that conversation, and he goes, I'm telling Jonathan, no, let's not write to write a book about AI, because if I do this right now, then once if you're going to release it, this topic might no longer be relevant. But I have a counter offer, and basically I proposed him my vision on the new Postgres book. We already had 50, we had dozens of Postgres books, but actually he believed in this idea, and then it took us 3 months probably to pitch and finalize the contract with the published with Manning, and turns out that was a good decision, because the book is quite useful. What I see, I receive feedback, people like it, people found it useful.
Amazing, man. Great story. Yeah. Great counter offer. Good job on that. I was asking you, before we get into the technical specifics of like how we can use Postgres for everything, I was just trying to get a sense of the historical relevancy of the now just use Postgres movement in the meme. Because I'll tell you, as a Kafka guy, someone who doesn't spend a lot of time in operational databases at all, I've used Postgres in the past. I have some experiences with it. I've used JSONB. I didn't even know about the extension ecosystem, so I'm far away from that. But around, I would say, maybe 2024, maybe late 23, I started like sort of seeing this meme, just use Postgres. And it also coincided with the so-called small data movement, which MotherDuck or DuckDB is the one kind of pushing this sort of movement, which is, again, if the listener is not aware, generally like the claim is, we had all these big data technologies made during the web scale era, all these distributed systems, all of these specialized systems for any type of thing, be it observability, logging, analytical processing, stream processing, everything really. And they're specialized, and they got sold to everybody. As you sort of alluded to earlier, you're trying to build your own Facebook at a company back in the day. Mm-hmm. Back in those web scale days where NoSQL was the hype, and also Kafka and everything. Everybody was trying to build sort of their next to Google company. Everybody was building their architectures to sort of attain this huge scale of like, I don't know if it was terabytes, maybe petabytes back in the day, and millions of requests. But turns out it didn't pan out. Most people cannot reach that scale. There's only 1 or 2 Ubers in the world, only 1 or 2 Amazons, stuff like that. So it turns out that all of these big data technologies are a little bit overkill for all of these use cases. Now they get the job done, but they're not optimal, because if you have to configure, let's say, a separate Flink cluster to stream process, let's say 100 messages a second, that's so much overhead in learning a new system, managing its components, setting up monitoring, hiring expertise for that little thing that's just passing 100 events a second. How much business value does it actually provide compared to, how much you're hiring for it? So I think this sort of trend, that's why I colloquially call the small data trend. Basically, use simple technologies when you can do it. And Postgres fits in that bucket, in my opinion. So I see that just use Postgres trend as part of this. And I was just trying to understand from you, it seems like at some point you also realized that, hey, Postgres supports all of these things. It has evolved. The extension ecosystem has had a lot of contributions in it. So yeah, do you have an idea of when you think like Postgres became so powerful, or was it just like throughout the years new stuff started getting contributed? I also just wanted to mention also from the commercial side, if I think since 2023, I've sort of seen like Supabase started raising large VC capital. We started seeing some Postgres offerings, which we're going to dive into later, but basically more of the like commercial space started offering Postgres solutions. So what's your general view on the trend? I just want to realize, like, when did I miss this, and when was this trend?
So I think that this trend, the Just Use Postgres, I heard about the Just Use Postgres motto, the phrase. I think around the time when I joined Yugabyte. So when I started working closely with different Postgres community members, my thinking is that the Just Use Postgres motto was just circulating within the core, like within a group of people, like quite large group of people who were championing for Postgres, who used Postgres on many successful projects successfully, and then just use that phrase for fun. And sometimes I would stumble upon questions on Reddit where someone would come and say, all right, I need to build the system. Okay, I want to use database X, technology Y, and another technology Z for this, how to glue everything together. And then someone from that group of people would come and say, like, look, my friend, you have to say Postgres in the list. And generally the other two requirements can be satisfied by Postgres, just use Postgres. And people would just finish this, phrase. It was more like a joke, more like something, more private, within a much smaller group of people. But then suddenly, that became a much bigger trend. How do you actually, before I explain my view on how this Just Use Postgres motto has to be treated, how do you perceive it? Like, how would you, when you stumble upon it, what was your reaction? What did it mean to you?
I loved it. I stumbled upon it in 23, 24 probably. Around the time I stumbled upon the small data movement, which I also found very intriguing at the time. I'm sure it was older than when I stumbled in, but I just saw it as this meme, and I sort of tied the two things together in my mind. Small data equals Just Use Postgres, because I saw them at the same time. And I think that makes a lot of sense, and it made a lot of sense to me. And I loved how, I think the meme became viral because it's just a good meme. Like every good joke, there's some truth to it, and when it's universally sort of understood as some truth, it becomes viral. You can't stop it. So I laughed at it when I first saw it, and then I thought a little bit more about it, and I thought, actually, this is genius. It makes a lot of sense. I can't really argue about it too much. It's like somebody saying, make something simple. You can never say, no, you're wrong. We have to make it complex. So in the same sense, if I can use Postgres for a majority of things, I have also, I worked at Confluent and I worked on Apache Kafka. So I've firsthand seen how these big data systems can be sort of misapplied and oversold to people who don't necessarily need it. The marketing engine of any big data infrastructure company just keeps on working and sort of creates this illusion that, hey, our solution is the perfect product for every need. Now, the solution is a perfect solution. The product is a perfect solution for a niche set of needs, for sure. And then the more you expand, the less it's a good solution, up until you get to, it's probably a bad solution, actually. Yeah. And, one company can do it, but if every company sort of says this for their product, then, I see basically you get a lot of misapplications. So, as an example, you may be using some big data technology when you're processing kilobytes a second. that's wasteful. Another big thing about the small data trend is that things have drastically changed since back in the day. As you said, 2009, when Facebook was still starting, I watched this old lecture of Mark Zuckerberg talking to engineers about Memcache and how they scaled Memcache. And again, I think they were on the LAMP stack, or at least they were using PHP. And it was a big thing back in that day to scale horizontally, yeah. So they just needed a lot of machines running commodity hardware. They were saying something around the lines that I don't know if their CPUs had 4 cores, something like that. So like a small amount of cores, maybe 1 gigahertz. I don't remember the numbers exactly. I've looked this up. But since then,
I don't remember the numbers as well.
Ever since then, the CPUs have increased drastically. Today, you can buy an AMD processor with 192 cores at high gigahertz, way more optimized architectures and everything. It's a vastly different world. So what back in the day took you, let's say, 1,000 machines or 100 machines, today you can fit on one. And, as a software problem, fitting infrastructure software on 1,000 machines versus one is a drastically different problem. It's a different field. One is distributed systems and the other isn't. In the distributed systems, you get all these edge cases about consistency and all the other issues there, basically, solving distributed consensus. And having been a distributed systems engineer, I've worked in Apache Kafka, I've thought about these problems. Everybody really goes to like the simplicity of a non-distributed system. And anybody who's running a distributed system will tell you, hey, Dennis, run a monolith as long as you can, and don't get into a distributed system until you need to. And back in the day, 2009, they needed to do that earlier, but I think today things have sort of changed where you don't really need to do it as much. Now, this is notwithstanding stuff like availability. Some people need very strict availability requirements, and for that you do need some sort of standby replica to be able to take over. But in a few sentences, that's how I would say. The meme makes a lot of sense to me, and it rides on this wave of small data or monoliths or simple software, and basically says don't overcomplicate your stack unless you need to or until you need to. And that until threshold is much higher than you expect, because as you would tell me now, Postgres can do a lot more than people think. People haven't updated their firmware of what hardware can do and what software can do, dating back, let's say, from 10 years ago. So, for example, some senior engineer that I might have worked with in my job, that guy might be working off of a mental model of a snapshot of, let's say, 10 years ago. And there's something wrong with that, but you have to update it because things have changed. And that snapshot might have been correct then, but I think in 2026, I think it's definitely not correct. So that's how I see it.
Yeah, I like this analogy with snapshots. Basically, I also, same as my story. When I joined Yugabyte, I had a snapshot of knowledge about Postgres based on my previous experience. But then I was doing those incremental snapshots that would update the main one. And those incremental snapshots let me just to look at the database with a different view and perception. But you're right, speaking about the small data movement and the architectural simplicity. Actually, because some of the people, this motto is a great, turned out to be a great marketing trick, because it's provocative. It's very provocative, but also, as you said, there is some truth to this. So Postgres will probably stand true for that claim, for that statement. However, it doesn't. People like those who read this, so some of the folks who see this message, this motto, they would think that it means that Postgres can replace all of the databases. No, it cannot. It cannot. So this just use Postgres basically can be perceived as just use what you already have. Yes. It can be, let's say, if you are a Java developer, before you start jumping on another programming language, just use Java, right? If you use Linux, and Linux also, and then you need to introduce some jobs that needs to be executed daily. You don't necessarily need to start using Airflow, right, for scheduling of those jobs. You can just use Cron. Cron is built in on Linux. So this is the same concept. And my point, of this Just Use Postgres is fight the architectural complexity. And the more time you spend in this software engineering high tech, the better you understand that every new component in your system it's going to be a headache for you in production. It's maintenance, it's security patches, and man, like I work as a software engineer these days. I stopped, doing DevRel. I got back to software engineering because right now with AI, the AI can write the code for me and I can iterate much faster, implementing the decisions. But I still have to spend days, maintaining, updating, and upgrading those systems. And I'm very resistant when my team wants to introduce a new component, just to make the queries faster. No. We can just go and probably just give more resources, more memory to our database instead of, bringing in another component and then fight, and then maintain it. So just the same with Postgres, just use Postgres book. What it means that for most of the use cases, as you said, not everyone is going to Facebook. Not everyone is going to become an enterprise company that needs to have those, like 4 nines of availability. Not everyone is going to have 1 million users who are hitting your backend with, dozens of millions of requests. That's why start, with the stack you already know and with the stack that will be able to carry you through if you're going to grow. And Postgres is right now as a general purpose database. Let's say you're building a GenAI application. You need to build those agents that are doing something. You have an option you can pay. You can use, let's say, Postgres or MySQL or another database for your transactional relational data, and then nearby you can run a vector database for the similarity search. But then let's say, but do you really need it right now? Because Postgres has this PG vector extension, which is free.
Exactly.
It's free, it's open source.
And it scales.
And but it's probably, the PG vector extension can be not as, it can still kind of have a lack of some of the features which are available in Pinecone or other vector database solutions. But first, you need to grow, you need to outgrow your current state, get to that moment when you literally need to switch from the PG vector of Postgres to Pinecone, or probably by that time, when you get to that level of scale, the PG vector can also be in a much better state.
Yeah, that's a good point. I want to touch on a few things you said. First, someone told me, and I haven't forgot this quote, is that AI can build your code, but it can't build your SLA, or it cannot automate your SLA in a way. You're still the one waking up at night. So that's big. Yeah. And I agree. In my experience as software engineer as well, when I just started, when I was just learning about everything, I was gung-ho in every technology. Let's use MongoDB. Let's use Kafka. Let's use this new thing. Let's use this new language. And since I got some experience, I'm like, no, let's keep it boring. Let's keep choose the most boring technology, the one we all know. Now, and you made a good point on just use Postgres. It doesn't mean migrate to Postgres. It doesn't mean drop MySQL or Oracle and use Postgres. No, it actually means just use what you can. Just use what you have. And I think we say it because my understanding is that Postgres is sort of the most popular database right now. I know it's probably kind of close in between, but if you put a gun to my head, I'll probably say Postgres is the most used one. And that's why we say, just use what you have. We're assuming you have Postgres, so just use that. And I kind of forgot what I was going to continue.
Then we're talking, let's say, Supabase, then part of your question of like what like Supabase, and overall we have right now an influx of different companies who are eventually making money on Postgres. They're building their products, they're building their managed services. And why? Let's because I saw you joined that conversation on the X Twitter today. You asked about MySQL, because we definitely have the hype cycles. Even let's say the Postgres is that kind of how many people call it the king of databases. It doesn't mean that it's going to persist over the years. It can persist, like what happened to Linux, because Linux is kind of one of the default databases for many projects. And the same can happen to Postgres. But what's unique about Postgres? Same as MySQL, or same as any other, like Kafka. We have Kafka, right? We have Hadoop, we have Spark, open source projects. And moreover, Kafka, Hadoop, and Spark, they belong to the Apache Software Foundation. But I before joining Yugabyte, I worked on another project. It's called Apache Ignite. It's a distributed in-memory system, distributed cache. Like I would usually call it Redis on steroids. And we know that most of the, probably, that's my opinion, most of the Apache projects, there is a vendor behind, like one major vendor who pays contributors to contribute to the project. In Kafka world, we obviously have Confluent and probably other like companies. In the Cassandra world, we had DataStax, we had Apple, because Apple is also a bigger user of Cassandra. And the story goes on. With Postgres, that's not the case. Obviously, all the Postgres, the core development team, all the Postgres committers and hackers, they are employed by some vendors. Many of them work for EDB, one of the biggest vendors. Some of them worked for Crunchy. Some of them worked for AWS, then Microsoft. But the community is structured in such a way that none of those vendors can get a majority seat within the community by employing most of there will be some, balances. It's like, I heard a story from one of the community members that there was the case when when some committer groups, like many committers, joined another company and there was some disbalance, and generally then some of the people some of their committership rights were taken away. So they lost that kind of voting right. So that, because that vendor kind of got a majority seat by employing many of those committers.
That's super interesting. I want to mention that too. I want to say what I know about the Apache Kafka and that sort of community country split. And just to give context to the readers really quick, we'll touch on this again, but I was asking you, why not just use MySQL? Or do you think that we'll have why just not use MySQL? And I think you'll tell me why in terms of MySQL community ownership, but you're spot on right. Apache Kafka, for example, is around 80-90%, rough numbers. I've done deep research on this, contributed by Confluent nowadays. Now it got bought by IBM, so that share is actually even growing. And one thing I keep repeating in the Kafka circle in particular, and you can tell me if that's true for Ignite too, or for Postgres, Kafka has a big community. So the reason these technologies like Spark and Kafka and Hadoop have won is because they have a very strong network effect, i.e. a lot of users. And people report bugs and sometimes contribute. But I think there's a little bit of a difference between a community member that uses your product and contributes every now and then versus somebody who's employed from a company that makes money off of Kafka. So let me give you an example. In Confluent, people work on Kafka every day. They solve bugs every day. They ship features every day. By comparison, somebody who's in Uber, they work on the data engineering team in Uber, and they work with a lot of technologies, and they use Kafka, and if they have a feature that they really need or a bug that really blocks them, they'll probably contribute a big feature to fix it. But apart from that, they're not active in terms of that. And that's fair. I'm not blaming anybody. That's exactly, you only have 8 hours in a day. You're employed to do something. You have to do what you have to do. But in that terms, I kind of see Kafka as very centralized in terms of contribution, because the majority contributions are people who actually give code, and the ones who are incentivized to do it are working at Confluent, for now at least. And that hasn't changed for many years. And there are contributors from other spaces, but they're, if you compare the volume, the impact, the amount of things shipped, it's vastly different. So if something happens and you kill Confluent today and nobody in that space ever works for Kafka again, I think development would stop immediately. Now, maybe it will pick back up by other people, but I'm just saying how it is. Can you tell me, in your experience, is that true for other projects? And tell me, is Postgres different? And then we can touch on MySQL if you want.
I think that many open source projects are similar to what you've described in relation to Kafka and Confluent. And that makes total sense, because first, let's say Confluent had that idea. They decided to open source, not the Confluent, but where is LinkedIn, that's right. Yeah. LinkedIn, and then eventually it's Apache Software Foundation is a great incubator and home for open source projects. You can, because they have a very great structure. Like everything basically, if you have that word of mouth and the project becomes as popular as Kafka, because the popularity of Kafka is much more superior than the one of Apache Ignite I worked for, then obviously the project is going to grow tremendously and everyone is going to benefit. But the problem is that what if another vendor, another company decides to start contributing to that? Will there be any roadblocks? And sometimes internally in conversations within a community, there can be some tensions, because let's say the majority of committers right now work for company X, another company want to enter, and another company is going to invest into that project by hiring engineers, paying them to contribute on a daily basis. But that company obviously pursues its own interest, and then clashes can start, and etc. Whatever. But some of the open source projects, like within the obviously Apache Software Foundation or their Cloud Native Foundation, they go beyond that phase, which is, I think, is inevitable, and then they will be, let's say, many of them might end up having a concept, a community which is structured in a way similar to Postgres, when right now there are many vendors, like a lot of those, the project first became popular enough, it's used everywhere, and basically the community, the core development team members, they work for various companies, and they work for those companies, because they have to earn somehow, but the companies really don't have a huge influence on the roadmap, on the growth over an open source technology. So this is what we have with Postgres, and I believe that this is the same we have with, probably we have the same with Kubernetes. It's also everywhere. And my thinking that also many companies contribute to it. And the point is, let's say if one of the Postgres companies or one of the Kubernetes companies just blows away, it's closed, nothing will happen to that open source project, because it's highly likely that the core community members who work for that company now will be able to continue their contribution, but they will be employed by other companies. So like the project will gain that momentum, and many companies are interested into contributing directly to it, and the future of the project is bright, and the project no longer depends, nor influenced by a particular single or a couple of vendors. So Postgres is definitely in this position right now. MySQL, unfortunately, is not, because the primary steward or owner is still Oracle.
Can you tell me a bit more about MySQL as somebody who doesn't really know fully the story? I know it was something with MariaDB. I actually don't. I can't recollect the story.
So I would say that I will retell what I learned, but I'm not the one who witnessed this, right? And I do not recognize myself as a MySQL user, and even worse, I probably used MySQL only once when we were writing, when I was working on another PHP project also in 2009. So this is going to be my view of what I've learned. So obviously, I worked for Sun Microsystems, and then I also worked for Oracle. But I was on the Java team. I was building JVM and GDK. And when Oracle was acquiring Sun, basically it was getting all of those technologies, including Java and MySQL. Java right now just feels exceptionally well. So like Oracle turned out to be a great steward of the technology and of the community. Just what they did works. Like right now we have this renaissance in the Java community. The language is being, modified and improved exceptionally well. The community is big as it was, and it keeps growing. So Java it keeps thriving. It keeps thriving. With MySQL, I know it doesn't look like it turned out this way, and there was an exit. One of the founding fathers or members of MySQL, eventually he quit Oracle after the acquisition, and then he spinned up MariaDB. But turns out that the customers of MySQL did not immediately move or migrate to MariaDB. And still, what we have right now is MySQL is how can I contribute to MySQL? Right? What if I want to, let's say, I don't know like an exact answer, but what I heard on the internet is that if someone wants to contribute, another company is interested, they want to come and contribute to MySQL and then quickly release a version, a patch, it's not easy to do it with the current structure and with the current approach. With Java, actually, if to talk good about Oracle, with Java, that's not the case. There is the OpenJDK project. And dozens of Oracle is not the only one who makes money in Java. There are many other companies like Azure and Microsoft and AWS. All of them, they have their own versions of JDK, and all of them contribute. their contributions are accepted to the Open JDK. And then Oracle also releases its own version of JDK. But with MySQL, that's not the case. Unfortunately, MySQL is not structured as Java, even as Java. And Oracle did not put proper attention to this database. And I think this is also one of the reasons why Postgres, stepped in. Oracle cleared effectively by not investing properly into MySQL, because MySQL was exceptionally popular. It's I think from what I can see, from what I can tell, MySQL is a great database. But the problem is that it was not supported. There was not probably enough of innovation, pace of development, pace of innovation because of the current structure. And then people realized, okay, if we have some troubles with MySQL, what's another option? And Postgres is here. And Postgres has also is open source, and Postgres is much more business friendly. Look, PlanetScale. If PlanetScale wants to start, offering their Postgres offering, they don't need to go and negotiate with someone. They just, go and sell Postgres.
I was just gonna mention them. By the way, that's a great motto. Postgres is just here for you. We can say that. Yeah. It seems like also from my vantage point that even MySQL talent is actually moving on to Postgres as well. I think they've realized what's happening. So from what I understand, PlanetScale was a MySQL company, and they recently introduced a Postgres offering, and they did big on marketing, like a $5 Postgres and different plans. So they seem to be shifting to Postgres. They also had a big talent from their side. The creator of the Vitess project, if you're familiar, that's, from what I understand, Vitess is this technology for sharding or hosting, sort of distributed MySQL. It was created at YouTube. And then Sugu, I'm not exactly sure how I pronounce the name, one of the creators, was a co-founder of PlanetScale and a CTO. And he worked there for 5 years, and he left. And then apparently maybe spent some years to clear any sort of non-competitive agreements and stuff. And then he was hired by Supabase to work on what's called now Multigres, which seems like is going to be the Vitess equivalent for Postgres, i.e. something that builds a distributed sort of Postgres. So you see major talent like that moving and focusing their efforts on Postgres as well. I think that's very telling as well.
Exactly. Or even what we had used to be the recent ClickHouse announcement. ClickHouse also now provides Postgres as a managed offering, and the ClickHouse is considered a competitor of the Tiger data of the timescale DB extension, because both actually help you to deal with your not only with your time series data and just general, and also with their different analytical workloads. But this is a testament that Postgres is very popular right now, and all those companies, it's easy for them if they really have some unique solution that can be built on Postgres. Like the PlanetScale likes to talk about, they're very obsessed about latency, performance, and reliability. They have this strong, deep engineering culture, and I like their product. Like they position this metal. There's Postgres on metal sounds cool. It's like, it feels like, all right, the real hardware, like when you can touch it. It's a great marketing, I think, approach. And if you can do generally, because people need it, yes, you can run Postgres on metal. You have, really, really well latent, but small latency in there. You pay less for hardware, you pay less for your infrastructure, and you have still big nines, let's call them 4 nines or 3 nines or whatever, of availability. Wonderful. And PlanetScale can do this. And I mean, like, there's smart people, they're database engineers, very lean team. And you need to be, you don't need to be fanatic. You need just to be, if you're curious about databases, in the end of the day, if Postgres is much more popular right now, why don't you apply your skills and your expertise? And it's always curious. And it's also, I think, was sort of some curiosity for them. Can we do this on Postgres? Can we repeat our success, which we have with MySQL right now, but on Postgres? And I think they will be able to do that. So it's also a good journey for the company.
Nice. Yeah, that I don't know anything about the technology actually, about PlanetScale, so I can't comment. I can only comment on their marketing, which is really good and effective because I keep seeing them on Twitter and X, even though I don't care about them. I don't care about databases, but I keep seeing their posts. Shout out to their founder. He's really funny on X. But continuing on this topic of everybody offering Postgres, so we had a few big announcements recently, maybe last 6 years, last 6 months, I'm sorry. I even posted about it. I made this big post about like using Postgres instead of Kafka that got very, very popular. And then there I did the calculation that in the last 12 months, we've had major investments in Postgres. So let me try to repeat them all and see. So first of all, we'll start with Supabase because I think they're the elephant in the room, pun intended. They 5x'd their valuation in the last 12 months. In a single year, they did 3 series. I won't get the numbers right, but they raised 380 million across 3 different series in a single year. That's unheard of. Then we had Snowflake acquire Crunchy Data for 250 million. Then we had Databricks acquire Neon for 1 billion as well. So major investments. And now we're having ClickHouse offer a Postgres offering. ClickHouse offer a Postgres offering as well. And we saw Databricks release this product called Lakebase. Snowflake is releasing managed Postgres. ClickHouse is releasing managed Postgres. And I looked through all their marketing, and they all have the same pitch. We're going to unify the operational and the analytical estate. So these companies were traditionally analytical. ClickHouse is warehousing and fast warehousing and real-time APIs. Databricks is warehousing and analytics and processing, and Snowflake is also just a warehouse. And I think they understand that, hey, most of our data is coming from a database anyway. We ought to probably expand our stack and own the data there and then make it really easy to move to. I recently did a post as well on all of these sort of technologies. I think Databricks acquired Mooncake, which we're building real-time ingestion into Iceberg and into Delta Lake. Snowflake acquired Crunchy, and then they released PG Lake, which is again an extension to move data to Iceberg and get Postgres. And the team is massively, massively talented over there. I've been talking to Marco from that team. I want to record a podcast with him too. Massively talented dude and really cool guy. And now with ClickHouse as well, I also want to talk about that extension. Yeah, I'll let you actually continue to speak a little bit because I'm not even sure where to take it. There's so much to talk about. There's so much happening basically in the space.
You know, like this conversation, and you are the reason why I eventually decided to look into this Postgres for analytics space because, after finishing this book in November, I decided to take some break and just to disconnect from anything. But as part of our agreement for this conversation, you said like, yeah, Denis, let me challenge you. Let's look into this. At least I want to discuss this. And I spent a week here, just evenings looking into this. I liked it. I liked to find. I liked what I read and I like what I found out during this time, because Postgres for analytics is it's a very great and possibly it's a very great bet. Meaning that it can turn out to be another interesting area and story that evolves around Postgres. But generally, how I see the structure, first you have, but there are different layers, like different forms of how you can use Postgres for analytics. The very first one is when you can build in you built in a columnar store directly in Postgres. And in this configuration, Postgres both your query engine and your data storage. It owns all the data you need to have for your analytical workloads. How do you do this in the Postgres community? I mentioned we have the timescale DB extension. We have Tigero data, and it's widely used for time series, and it's also used beyond that. And they also have the columnar store. They have this hybrid store. So basically, you install the extension, and your Postgres is going to have both row store and columnar store. Also, there was the project, and there is still a project called Hydra columnar. So the concept is quite similar to what their timescale DB does, but with some specificities. I'm not sure how they how healthy the Hydra is right now, but that is another columnar store for Postgres. But timescale DB does really well. The Tiger data, they're growing too fast. So this is Postgres when you use Postgres for analytics as the database that stores both columnar and raw data. The second approach is what you mentioned is the PG Lake extension or PG DuckDB extension and the PG Mooncake. So in those configurations, Postgres is there. You use Postgres as a query engine for your analytical workloads, but the data is stored somewhere else. And that somewhere else can be S3 bucket with your Parquet files, and then you have this iceberg tables on top. And what PG DuckDB, essentially what PG DuckDB, PG Lake, or PG Mooncake do, essentially they integrate Postgres with DuckDB. And and DuckDB can be embedded into Postgres, so DuckDB can run nearby in another process. But the point is, whenever you want, your application connects to Postgres, and it wants to run some query that gets data from an iceberg table somewhere, Postgres just redirects this query to a friend of his, to DuckDB, and DuckDB gets this data. So this is a great duo, actually. This is a great open source duo. I love to see how both technologies collaborated, and there is a collaboration at the community level, from what I can understand. ClickHouse, and ClickHouse is quite offers the same approach with the PG ClickHouse extension. Let's say you have data in Postgres, you have data in ClickHouse, and then if your preference is to use Postgres as the only query engine that gets transaction and analytical data, then you can use the PG ClickHouse extension. So this is the second approach. The third one we can discuss later. It's related to Supabase, but I see that you wanna.
Well, first shout out DuckDB, because you're right. PG Lake, PG Moonlink. I dare to call these things wrappers on top of PG DuckDB, which is doing the heavy lifting of talking iceberg and doing a lot. Not to say those extensions still do a lot of things, but PG DuckDB is awesome, and that's the secret sauce. There's also, there's a lot of, the devil is in the details when you're building a Postgres extension. When I talked to Marco again from Crunchy, he showed me a lot of edge cases which depend a lot on, for example, whether you run the DuckDB in the same process, how you interface with the duck interfaces, running out of memory, all sorts of other stuff that sort of went over my head, or I didn't remember because I'm not into the details of a database that much, but there's really a lot of complexity. Do you choose to proxy out of the SQL to DuckDB, or do you parse it yourself and then translate in a certain way, etc.? There's so much complexity in these things. But the big difference between also DuckDB and ClickHouse, or PG ClickHouse, is that DuckDB is embedded. So when you run, from what I understand, correct me if I'm wrong, but when you run PG Lake or PG Moonlink, the DuckDB process runs inside the same machine that the Postgres is on. So it's part of it. I think it spawns a separate process, depending. I think PG Lake spawns a separate process. I think Moonlink may run it embedded in the same process. And the big thing about Postgres is that every connection is a separate process too. So there's a lot of edge cases there. But it's all in this one package. Whereas the PG ClickHouse, from what I understand, that it's actually just, you just give it a ClickHouse URL, and it assumes that you're storing your data in a ClickHouse somewhere else. Now, in theory, you could set up some orchestration to run it inside the same machine, but I think ClickHouse are optimizing for and assuming that you're running ClickHouse with them, and they're just trying to find a way to sort of migrate the data in an easier way. Their blog post had a very good point on this, which was, hey, if you're migrating your workloads from Postgres and you want to start using ClickHouse, okay, you can migrate the data easy. You set up a pipe. You can set up Kafka for this too, but they have their own feature called a ClickPipe or something, and the data is just going to migrate. But the devil is in the clients. You may have 100 clients that have an SQL code that talks to Postgres, that uses a Postgres supporting ORM library or something like that. That's the work, having to connect to 10 different teams, create a Jira ticket for them and tell them, hey, migrate to ClickHouse, with different languages and everything. That's a huge amount of work. And what they are trying to sort of do is, well, actually, you can just send SQL to Postgres, and we'll route it to ClickHouse, and we'll give you the result. And I think that's great. I want to ask you what you think. What do you think about the idea of actually running ClickHouse embedded in a way or in the same sort of machine as Postgres? In theory, ClickHouse can be run in a single node. It's C++. I think in theory, you could have, let's say, an alternative PG House extension, because PG ClickHouse is already taken, cunningly enough. But PG House extension that just runs, let's say, a separate process that runs ClickHouse inside the Postgres, and you all have everything in a single node that you can scale up. Because my concern or my thinking is also that you may not need that big of a database as a ClickHouse. You may not need a big ClickHouse database. You probably just want the vectorized execution of a columnar store, but not necessarily 3 nodes or passing gigabytes a second. What do you think about that idea?
Collocating 2 different databases like Postgres and ClickHouse on the same node, on the same machine, might not be really necessary. Because when it comes to those integrations, as you said, we have this Postgres foreign data wrappers. And basically, when you talk about PG.DuckDB, this PG.DuckDB, like DuckDB is literally embedded into the Postgres process. You start Postgres and PG.DuckDB runs within the same operating system process. With PG Lake is different. Like you talk to Marco, one of the key contributors to the PG Lake. And in their configuration, like PG.DuckDB is a different process, but they are collocated. They're running on the same machine with Postgres. Nevertheless, in that configuration, but that, let's say, DuckDB then needs to connect to where? It needs to connect probably to some lakehouse, which is deployed somewhere else. And the key here is to implement those pushdowns. Because an extension like PG.DuckDB, if it just, gets a query from Postgres, connects PG.DuckDB, then connects to that lakehouse, gets all the required data, and then returns everything to Postgres, then there is just massive data movement across different database query layers, and Postgres then needs to do this. That's not efficient. That's why many of those extensions, they're trying hard to implement so-called pushdowns. It's when Postgres asks, okay, I want to run this aggregate over this data set, and this aggregate query goes to DuckDB, then sends it to that lakehouse, and it's executed right in the lakehouse, and you're getting, just a partially computed result, or just much smaller result, or just a complete result, and you.
If I can try to simplify that as far as I understand it, is like. Because if you're storing data, let's say on S3 scales more than Postgres. A single Postgres machine can scale to whatever terabytes, S3 can have petabytes. So if you want to do like a join or group by or sum of over like a petabyte of data, if you return all that petabyte of data to Postgres to run inside its own engine, to run out of memory, to blow up and kill your other workloads. But if you can push it down to the big database that's scaled for that, as local as you can run the computations to the workload, the more efficient it is. And then you can only return that completed result to Postgres. But you say, so these pushdown queries, Iceberg, for example, there's no lakehouse that's Iceberg. It's just S3 with a particular format of, let's say, Parquet files. So in that situation, I think even DuckDB will be running on Postgres, so you would need to push it down to somewhere else. I think the pushdown, from what you're referring to, at least with DuckDB, is that at least you can run the aggregations in the DuckDB columnar engine, which is way more efficient for large-scale columnar aggregations than Postgres. Does that sound correct?
Here, it's something can be done within DuckDB. If DuckDB already has this data, if it stores some copy of the data, and my guess is that that Iceberg is basically a specification, right? It's not a ready to be used technology. But if let's say that Iceberg provider you have that Iceberg tables running, and if that implementation of Iceberg by AWS or another company also has some execution engine, then DuckDB can connect to that execution engine, and that execution engine on the storage side can basically do those aggregates for you, and even DuckDB. This is basically, I don't know precisely who does what, but I did not look, deeply, but this is what I would be doing as a database engineer if I need to optimize everything. I think that's
a good point on what the Iceberg provider should probably think about doing. And I think that space is still evolving, the Iceberg, so I don't think it's clearly defined where we'll separate the barriers. And also a final touch on the analytics side is that this, if we talk about small data, I still think that running everything in a single binary in Postgres, while it may be operationally a little bit heavy, would you tell somebody who says has let's say 100 gigabytes in Postgres to move the data to Iceberg or to ClickHouse in the first case?
So what I would do, I'm planning actually to do this in the next following weeks. I want people to understand different forms of Postgres for analytics, and then to pick the best option. Because for some people, it will be more than enough just to use timescale DB extension. You have just Postgres, you load your data, you can use columnar store, you have compressions. It's a wonderful extension. That can be much more than enough for you. If, let's say, that's not the way to go for you for some reason, probably you already use ClickHouse, or you can use another analytical database. Okay, then you can, but you want for some reason query from Postgres because let's say your applications are written just for Postgres. You don't want to introduce other application drivers. You don't want to build, other services that would pull the data from another database and then join or merge it from Postgres. No, you can use an extension like pg.db, pg-lake, etc. Because then you can connect to a broad range of different lake houses, analytical systems. I think through DuckDB at least. And lastly, the third approach, which I did not mention, is when Postgres is just a provider of the data. Take Supabase ETL, which you looked into.
Right,
basically, it takes the data from Supabase, moves to your lakehouse, like S3, like in Parquet files. And then after that, Supabase no longer cares. If you want to query that data, you already have an ecosystem of tools which were designed for that particular storage. You don't need to use any Postgres extension. Postgres is just a provider of this data. It ships the data as fast as possible to your lakehouse, and then you use, some tool that was created by AWS or another company to query the data because you already use it. My thinking is that the acquisition of Neon by Databricks, because right now Neon internally at Databricks is positioned as Lakebase. The Lakebase is basically Postgres, and the idea is Databricks now owns Postgres as well. So they own the transactional data. Every lakehouse needs the transactional data. And if you own and right now if you own and Postgres eventually became one of probably the number one relational database right now because of the current state of what we have in the database market. And if, let's say, you are owning the customers, the users who use Postgres for transactional workloads, then they can easily move your data to your lake houses and you can upsell them analytical solutions, right? Yes. And this is your customer, you own everything. And Neon helps with this. With Neon, you run Neon. Neon can just stream data to Lakehouse, to Lakehouse or Databricks, and you own this whole ecosystem. Snowflake, and my thinking that Snowflake with PG-lake with Crunchy, the same story. And ClickHouse, I think, is doing the same. They want to do the same. They want to compete to Snowflake. They want to compete to Databricks by releasing their Postgres offering. So you have three options. Postgres as a columnar store, Postgres as query engine, where you use extensions for DuckDB, etc. to query, and Postgres just as an ETL. You transmit data to your lakehouse, and then you use some other tools that were created for that lakehouse to work with your analytical data. So I would advise first to understand what you already have in your ecosystem. Are you planning to use any real lakehouse? If you just building some time series application, analytical application for finance or for retail, and you just need to run some analytical workloads, you don't have any plans to work with any lakehouse, you can just use timescale DB extension. Or probably you can use another analytical database and use some extension that will let you query from Postgres both. If you need lakehouse, if you're already using lakehouse, you can just take a look at a different concept, what Supabase ETL does or what Neon does with Databricks.
Great point. Yeah, I agree with you. And risking to talk too much about commercial, I feel like a VC a little bit. We've only talked about what these companies are doing and where money is spent. And I also have the VC vest, so I guess I can really pass as a VC today. But I think also that these companies are moving to Postgres because they're realizing that Postgres is what's used as a real VC. I'm going to say the word AI, AI agents, whatever. I hate that word. It's overused. It's just hype. But talking seriously, if you, a developer, want to build an application that uses an LLM, let's say the ChatGPT API or something like that, everybody is selling you some solution. Oh, our AI agents, streaming agents. Every data infra company has, in the last year, rebranded to an AI-first company, and their solution is the best for AI, including Snowflake, Database, everything. And I think they're realizing that, hey, actually, nobody is bottlenecked on data infrastructure for AI. Everybody is bottlenecked on figuring out how to actually use it in the first place. And the first thing that you're going to use your application that uses AI is going to be a database. It doesn't matter if you're using AI or not, by the way. Any application uses a database as the very first thing. And Postgres is the default database today. So chances are if you're building an AI agent, AI application, you will be using Postgres. And I have a sense that the companies are trying to sort of catch that wave of new AI workloads, because that just having an AI workload onboarded to your product is already going to raise your valuation by a lot, because investors are going to see you as an AI company, and AI companies today receive a lot of money and receive a big multiple on their valuation. So from an investor point of view, finance is just a good thing to focus on. That's how I see it. Do you agree?
With the AI, I don't know. I understand. Let's say I understand why Neon focuses a lot on this AI story, because they sell Postgres as a service, and there from the very first day when I met Nikita at one of the conferences, he was actually showing me what's supposed to be near. He was telling me, "Hey, look, I'll show you a quick demo. We are going to launch this product in a couple of months. We are going to call." He didn't tell me the name, but that was Neon, and he was obsessed about the startup time. So one of the biggest and first features, he was telling, like, look how quickly my Postgres can be provisioned for you, and this is provisioned in the cloud, and then the branching, and then everything like around that. So he was not building for AI agents those days, because ChatGPT has not been released, I think, yet. But the foundation was right. Because right now, if there is any startup like Replit or another company that does something for AI, when you need to spin up, your AI agent, and that AI agent needs to store data somewhere, retrieve data from somewhere, then Neon is an exceptional foundation for that, because this is how Neon was designed. Insanely fast startup times, and then the branching. So for those companies, they like, if you have a startup, you want to do something, you need to spin up a bunch of those agents really quick, because you are doing the software as a service. And then they're already Postgres providers, and for Neon that was the case. If you're building something, let's say, if you're not building, something comparable to Neon, if you're not building something comparable to Replit, where you can just prompt engineer and design your applications with help of your agents, then Postgres is still good, but any other database is also good enough for GenAI, because as you said, every agent, every MCP server still needs to have data.
Yep.
It can be transactional data, which is unique to your business. It can be some descriptions. It can be some embeddings. And if you want your AI capability to be useful, then it needs to provide reasonable responses, reasonable suggestions. And if you want to make AI to make a reasonable AI solution, then the data needs to be accurate. The data needs to be there. And Postgres, let's say Postgres has not only, Postgres has full text search. Postgres has the similarity search. You can build the hybrid search engine with Postgres if you want, which means that before, let's say, running that similarity search over a bunch of data, you can first run this keyword search with the full text search, just filter out this subset of the data, and then you can run the similarity search. Postgres can do that. Many other databases, I think, also can do that. But the point is, what are you ready for right now? If Postgres is your choice because you already used it in the past,
or because it certainly will meet your requirements, then Postgres has everything you need for the Gen AI, for your AI applications. And then, as I said in the very beginning, if at some point you realize that now you hit the wall, you hit the limit, Postgres cannot help you scale, then, okay, you can take a look at different Postgres providers like Neon or Supabase and see if their AI approach with Postgres is already optimized, and you can migrate from your on-prem Postgres deployment to their deployment easily. Or if nothing works, then you can migrate to a specialized vector database, different way, but start small, start simple. This is the main. If you will be able to survive, then VCs will give you another round, and then you will use that round to build, the next scale of your platform. But what's important right now, you can use Claude Code to prototype and iterate quickly because AI can write the code for you, and you can use Postgres because it has all the essential capabilities needed for the Gen AI agents. Just do this, scale, win, and then see if VCs are ready to give you another round for the next phase.
Yeah, I think that's a good point on the Cloud Code part, because if Postgres contains everything, you don't even necessarily need to learn the extensions. You can ask the AI to just write the integration code or the installation or whatever and tell you about the extensions itself. So it's not like you even need necessarily a managed solution to spin up those extensions and provide you with a good interface for them. I think AI could be in theory good enough. But with risk of just talking about AI and analytics, I want to talk about all the features that Postgres can do. I want to talk about what you've written in your book, right? We haven't talked about it yet. So let's try to speedrun to all the features of Postgres that you've talked about in your book. And you just mentioned text search, I think you mentioned.
Mm-hmm.
I was also going to mention that Tiger Data recently open sourced their BM25 search algorithm, which is basically a very good search algorithm in the PG text search extension.
Mm-hmm.
So that's one new thing. Tell me about text search, what Postgres supports, how it compares in your opinion, and then just speedrun through all the other stuff like geodata and anything else you can think of.
Yeah, the first how it's called section of the book. It primarily talks about Postgres as a relational database. It talks about the Postgres, which many of us already know. But there are also some of the unique parts. You will learn, especially if you're a newcomer or you're migrating, let's say, from, I saw feedback from those who are moving away from SQL Server or MySQL these days. They send me notes saying, all right, you're good. We found your book very helpful. Because the very first chapters show them, okay, look, Postgres also has all those essential relational capabilities and transactions and joins and materialized views and stored procedures, if you like. That's the beginning. Then we transition to the modern SQL. So the modern SQL is not my term. It was coined by, I forgot his name. Sorry. Let me find it. Modern SQL. Marcus. His name is Marcus. And this...
Renowned.
Yeah, I think... Yeah, Marcus Renowned. Yeah, that's right. So I make a statement that I have a modern SQL chapter in the book, in the first section, and we talk about it. And when I had the peer reviews of the book when it was in production in development, some of the well-known Postgres experts, they just said that, look, I'm surprised I'm already learning even from that part of the book because cool. It's interesting. That modern SQL part will be interesting for those who had that snapshot of Postgres that was taken, let's say, in early 2000s, right, or to 20th back in the days. And then we transition into JSON and full text search in the second section, because why it's dedicated? Because JSON and full text search is natively supported by the core database engine. You don't need to install any extension. It's in Postgres. With text search, though, there is a special, you have all the basics which are necessary to enable full text search queries in your database. There is a special TS vector type, data type. There are special operators. There are specialized index types, which will let you run efficient full text search queries. This still might not be enough. Those built-in capabilities, they do not match what Elasticsearch has. But the point is, you might not need what Elasticsearch has. And what Postgres has might be enough for your current use case. Right. What the Tiger Data folks did, I think they have many clients. And right now they're also in this GenAI landscape. They have the PG Vector Scale extension. They have the PGI extension. They're investing into that. And their clients definitely want to use the hybrid search. And they probably want to have something which is much more comparable to their Elasticsearch's ranking algorithm, BM2. And basically, so right with the PG text search extension right now, you can get and take advantage of the same algorithm, ranking algorithm, which will improve. And it's built on top of what Postgres has, on top of the native full text search capabilities. So this is great addition. So this is basically the continuation of the Postgres evolution within the full text search space. But the Tiger Data team was not the first. Before the Tiger Data team, we have ParadeDB, and they had PG search extension that also enables their BM25 ranking, but they are architecturally different. Because the PG text search by the Tiger Data team, it's basically built, it's native, it's built into Postgres. It's just, I think it's written from scratch. That's my understanding. With ParadeDB, they reuse Lucene, they reuse some other projects. So it's a little bit different.
Got a big difference.
Yeah. So this is full text search. I also like to exploring it. And right now we're just getting more attention. And the rest of the book, we obviously have a chapter about GenAI, how to use Postgres as a vector database. Then there is some geospatial. PostGIS is the main geospatial extension. And actually Postgres, many treat it as a separate database because this is one of the, there are just two major solutions in the GIS geospatial landscape, and one of them is Postgres. The second one is some proprietary paid database. And then also we have the message queue use case, which should be close to your heart.
Very close.
But this is the chapter which I did not want to work on because I was very skeptical. And why I decided to add it to the book, and I did not regret that I don't regret that I did that. Is when we released the book in early access version, it was in January 2025, the very first chapters were available, and I just went to Reddit, to the Postgres subreddit, and said, guys, look, I'm working on this book, feedback is welcomed, etc. And that was a very engaging conversation. And what I saw, many folks suggested me, Denis, table of contents looks good. We look forward to this book. But what the hell, where is the topic about Postgres as a message queue? And I had a couple of, comments like this, and under those comments, I saw, let's say, 25, 30 thumbs up, meaning that people wanted to see it. And then I go to Jonathan Genick, to my acquisition editor, and say, Jonathan, okay, we need just to add this chapter about message queues, just because people want to see it. I personally thought that this is too much. Just too much of a stretch, probably. We don't need to talk about it. But then I realized, no, in fact, it depends, because sometimes you need to have, some simple message queue or some simple job scheduler. Yes. And Postgres, and pretty much every relational database can be used for that. But Postgres also has specialized extensions for this. And Postgres internally can just work really well. It doesn't replace Kafka at all. And I would be interested to hear your opinion. Where do you think Kafka still stands out? But this is the last chapter, and I truly, after writing this chapter, I realized that my skepticism right now is gone. Postgres can be used, but also at the same time, I would never ever say that, no, you don't need Kafka, you can use Postgres. Because when I published this book, and Viktor Gamov, whom you probably know, he sent me a note saying, Denis, what does it mean? That are you now suggesting, to replace Kafka with Postgres? I said, no. And I explained him my vision. He said, that makes sense. And the vision is basically what we're discussing right now. Just use what you have. If Postgres is no longer enough for you, or if from the very beginning you understand that only Kafka can handle this, use Kafka. You don't need to be fanatic. Just be reasonable engineer. Use your engineering cycles wisely.
Yeah, I can speak on that a little bit. Well, I think first we have to really differentiate between the use cases of, I call it like a queuing system, and I call it PubSub, but technically it's not correct to call it PubSub because everything is publish subscribe, but call it like a log-based messaging system. Mm-hmm. So in normal queuing, you have different semantics. The semantic is I write the message and whoever reads it sort of consumes it, and it's not available to anybody else anymore. Usually that's how a queue is understood to work. You pop it out the end of the queue.
And it's easy to implement this one on any database system.
Very easy to implement, yes.
It's just yeah.
So the first caveat I have to say is many people confuse Kafka for a queue, and Kafka has never been a queue, and it's only recently in the last year starting to release a preview feature where it exposes some queue-like semantics. So the first thing is if you're using Kafka for a queue, you're doing it wrong, and you're probably in a world of pain because you have to implement your own logic on top of Kafka. Now, queues are easy to implement in general. You can implement it on top of Kafka, but it's working, it's easy to get wrong. So from that point of view, I think for queues, Postgres is amazing. I think a competitor more along the lines is something like a RabbitMQ, which Rabbit is a good queue, and it has a lot of very rich features in terms of, I'm not even sure of the full feature set, but you can subscribe to particular regexes, you can filter, you can route messages depending on complex rules. So that's a very heavyweight queue. But for the most simple use cases, which I think almost every application has a queue, one of the first things you hit in building any sort of web app or anything is a queue-like functionality. And what is a queue-like functionality it's asynchronous processing. I sign up on the website, I click sign up, it says, we've sent you an email. The request response cycle, the HTTP request to the server to send the email, it wants to send the email asynchronously. It doesn't want to wait for the email to get sent for it to return a response to me to say we've sent it. No, usually it's always done in an asynchronous way. So that's the first thing you want to do. You want to store that, send the email request somewhere so something can process it asynchronously. That's the simplest way I can introduce a queue system. You can do this in Postgres super easily. You don't even need an extension for that. You can just use a simple Boolean flag, which is like, message, emails to send, is it sent or not, and then something reads it and sends. So, but then there are extensions for this that make it even easier to use in high scale. Yeah. So I think for that, you should always use Postgres, and it scales absurdly high. People don't appreciate how much it scales. I ran some tests. I did not even use PGMQ. Okay. I ran some tests.
Okay.
I was comparing Kafka to Postgres, but I also compared queue-like scenarios, or just tested it. So I ran my own code. So I asked Claude and I reviewed the code. We wrote our own sort of queue system, which was literally, I'm looking at it now, it's like 20 lines of SQL, okay, something like that. Just a simple insert, and then just a simple insert and read.
Yeah, select insert. You don't even need you might need to have some update. Let's say when the message is retrieved from the queue, then you do update, and that's it.
Yeah,
the message is not visible.
The keyword was select for update skip locked. So I did that, and I ran the test on a single node, a 4 vCPU node on AWS. It was a C7i X large, and I got it to do up to 2,885 messages a second of processing. That's of inserts and reads at the same time. And the write latency was 2.4 milliseconds. The P99 was 2.4 milliseconds, and the read latency, the P99 again, was 4.2 milliseconds. And the total end-to-end from insertion to read was 18 milliseconds of P99. That is world-class for Postgres. And the server was at 60% CPU. And that was with 25 total clients. So it goes to show just the simplest machine, the cheapest AWS machine with 4 vCPU scales absurdly high for a queue. Now, this is a Postgres running just for queues. I wouldn't recommend you run it, or maybe you don't want to run it alongside your normal operational database, because you can get into issues. There's trade-offs in both. So that's great. So that's the queue part. So getting the queue part out of the way, I think it scales superbly, and you don't really need it. If you have a simple use case, you shouldn't even consider using a queue unless you really fight, end in some difficult situation. There's also we don't have enough time to cover everything, but also, one of the problems with using Postgres as a queue is migrating after. So you write this custom SQL, imagine 5 years down the line, you have 100 applications using it and you want to migrate to Rabbit suddenly you have to change those 100 applications. So a good practice is to use some sort of library that sort of wraps it behind your own API, and you can like switch it behind like the implementation at some point. And now for Kafka, Kafka is a little bit more complex in the sense that the difference between Kafka and a queue, broadly speaking, is that a single message that gets read into Kafka is read multiple times by different consumers. And ordering is strict, and it's important to have ordering. So it has head-of-line blocking because of ordering. And this is a little bit nuanced, but in a queue system, if you produce, let's say, 10 messages, and we pop message by message by message, if one of my consumers pops the message, starts processing it, and fails, that message is not consumed at the end of the day, and it will remain unconsumed. And at this point you decide, while it's processing this message, do I let consumers read future messages or not? If you let them read future messages, you have bigger throughput, but you may get out of order processing, because if we fail at message 8, and it's taking 10 seconds to respond to the failure, and we wrote 10 new messages and those were read, eventually somebody will read message number 8 after message 18. So they'll read message 18 and then they'll read message 8 because that was failed. That's out of order processing allegedly. Kafka goes to lengths to avoid this by separating things by partitions and introducing head-of-line blocking. So in the Kafka case, until you process message 8, you cannot read message 9, basically, roughly speaking. You read them in batches, so you read like 10, 20 messages at a time or 100. But anyway, so that's one difference. And then you write this in Kafka, and then many consumers read it at once in a thing called consumer group. So to implement this functionality on top of Postgres, you need a little bit more code. I again wrote my own code for this, again SQL, a little bit more complex. It had locking using a different table because the ordering had to be preserved, so the requirements are kind of stricter. But again, total SQL, probably 40 lines, 50 lines, whatever, 100, depending on. And I ran this, and again, the throughput was amazing. I got, again, a single node, c7i.xlarge, and I ran a lot of other tests. I can link to the article, but just a single node did 5,000 messages a second. And the read rate, because here we have read fan out, as I said, every record is read multiple times. I think I did a 5x read rate. So I did 25,000 messages a second being read, i.e. for every one message you write, it was read 5 times by 5 different consumers. So I did 5,000 messages a second and 25,000 messages read a second from a single 4 vCPU machine. These are incredible numbers. I can tell you from being in the Kafka space, we have public studies or reports, surveys by vendors that publicly say, hey, 50% of our workloads use Kafka for less than 10 megabytes a second of write rate. Some say that 50% is 1 megabyte a second. So scale-wise, Postgres scales to match what most people use Kafka for. And Kafka wasn't built for 5,000 messages a second. Kafka was built for 100,000 messages a second and even more. It was always built for that. It was built for LinkedIn scale. And one of the big problems with Kafka is it got adopted by many people who don't have that scale. Now, I don't want to talk too much about this topic because we're running out of time, but in a few words, Kafka still has a lot of advantages over Postgres in the sense that it's fully replicated, it's very highly available, and it's very durable. And it makes these things, it runs out of the box in a highly durable and highly available state, whereas with Postgres, you have to change more things. The other big thing about Kafka is the network effect. The community is very big, and every big data tool, ClickHouse, Snowflake, anything you can think of, connects to Kafka in a very first-class integration sort of way. And you have schema support in Kafka, which you also do, in Postgres, but in Kafka you support Avro schemas, JSON schemas, protobuf schemas, you support evolution. And you have a rich Connect ecosystem, which is basically like a data integration tool of Kafka, which lets you connect Kafka data to many other tools. So the ecosystem you cannot replicate with Postgres. And the sole fact that you don't have the Kafka API means you don't have the ecosystem. And there are ways to circumvent this. I think somebody can and should write a PG Kafka extension where you literally implement the Kafka API on top of Postgres. I have one favorite open source project called Tansu, which implements the Kafka API and supports writing data to a Postgres database. That's my favorite project actually in the Kafka space right now. But I think that's really the big difference. You just don't have the ecosystem, and when you want to support some high requirements, meaning like very high scale, or easy scalability or fast scalability or high durability, high availability, Kafka does it out of the box, and Postgres will require some custom set solution. But nevertheless, as the Kafka guy, I call myself the Kafka guy and I write about Kafka. I would say just use Postgres most of the time, guys, unless you really need it, unless you have a big enterprise setting where you have hundreds of clients to connect to your Kafka. Postgres is also bad at handling many clients, but you can circumvent that with a connection pooler. But basically just use Postgres until you no longer need to. That's my advice in one phrase.
Yeah, I like this overview, because when I was working on the chapter, and every chapter is full of practical examples. You're supposed to not just read this book, you're supposed to open up your laptop and code through a chapter. You need to reproduce all the steps on your end, because I wanted the reader to have that feeling that, all right, yeah, now I can see that Postgres can be, now I can just approve myself that Postgres can be used for full text search or as a message queue, but you need to complete those steps. But when I was working on that one, I exactly had that idea. Like I implemented and I showed how to implement a basic message queue. You put a message and then the first consumer gets it and the other consumers will not see it. But then the next step, let's say, okay, but what if I want to deliver this message to multiple consumers? This is an extra kind of effort to implement on top of Postgres. What if, like as you said, then everything needs to be in proper order? Because this is important in banking, right? If there is some streaming, solution in banking, you cannot, just process one message, before the other. There's just a stream of events, like we call them events, right? Stream of events, and every event has to be ordered. Again, it's an extra effort for Postgres. And eventually, my suggestion is, like you say, okay, if you already use Postgres, like let's take this use case. If your team just needs to build some message queue. Now, let's put aside the streaming. If you want to build some event streaming processing platform, right, with all that partitioning, scale, and etc., multiple consumers and ordering, then probably it's better to start with Kafka right away. That's my thinking, probably. This is at least I think, this is my way of thinking as an engineer. But if, let's say, you just need to build the job scheduler, a message queue, you already know how to use Postgres, you already use Postgres, try to use Postgres as a message queue. But you need to be aware of the Postgres here limitations, like you will not be notified, your consumers will not be notified automatically. If there is a new event, you need to have some polling mechanism. Some of the Postgres drivers, poll the tables automatically. Then, there is a list, like people can check this offline. Having said that, again, as an engineer, as you said, start simple, try to use what you already have. Just be, because the Kafka, deserves to have that popularity. And right now, I, as an engineer, before I even started working on the chapter of Postgres, if someone stopped by me and said, Denis, okay, we need to have that message queue. So what we would use, and I would start looking into ActiveMQ, RabbitMQ, Kafka. I would be looking only into those solutions. I will not even be considering Postgres. But now I will also consider Postgres as well.
Sure.
And my point is that more engineers need to realize that a tool set is broader. So have a look. Yeah, start small, start simple. If you need Kafka, Kafka is here to stay. Postgres doesn't replace Kafka. Because Kafka is, as you described, you described exceptionally well. Kafka is so much more than a message queue. But message queues also can be implemented with relational databases such as Postgres.
Yeah, in summary, just use Postgres until you can't, basically. Denis, thank you so much for this appearance in this podcast. People should try the book out. They should read it. They should buy it. Please tell me, where can they get it? Is it out now? What's up with that?
Yeah, it's published. You can get a hard copy. You can get a ebook copy. There is even an audio format. I don't know how it works. I have not tried to listen to my book, but you can even get I don't know, because I don't know, like you're supposed to run code snippets, but there is some audio. I'm curious. I need to listen to it. But generally, yeah, you can go to the Manning. It's published with Manning. You can go to the Manning website. You can get the book there. Or you can just find it on Amazon if Amazon delivers to your country.
But the simplest, if you want to get it right now, immediately, today, then just get an ebook copy and start reading, because you would still, even when you buy a hard copy, you're getting the ebook copy free from Manning. And it's essential because you're supposed, you can read it, but then I want you to copy and paste, the code and SQL snippets. And also, yes, Stan, the publisher gave you a code. We can share the code in the description and everywhere. So the code should expire on March 1st this year. And you can use it to get a book, I think, with a 50% off.
Oh, wow.
That's,
I didn't know it was 50%.
Yeah,
okay, everyone.
But we can double check, but usually it's 50 off. You just go to the Manning website, you get the book, you add it to your cart, you apply the code, and you get a 50% off. So this is...
Okay, well, you heard it here first then. If you want to just use Postgres and buy the book, you use code, I have the code 2minute stream, 2minute stream, one word. And stream is with a capital S for allegedly 50% off. I'll share it in the description too. I recommend the book. I thank you so much, Denis, for coming on. This was an awesome discussion. I wish we had more time. We have so much more to talk about. The Postgres space is just endless. And I'm so excited to see what's happening there. And I feel there's so much energy. It's really a Postgres renaissance, and that's what I call it. So thank you for talking through the Postgres renaissance with me. And yeah, I wish you a great day, man.
Yeah, likewise. And thanks for inviting me, because finally I followed you for a while and finally we have a chance to have them. I think that's our first conversation, but then we will definitely stay in touch and we will continue, discussing all the streaming and database related matters, at least privately.
Yeah, because there will be more things happening, I'm sure, with time.
Yep.
All right, thank you so much. Thank you.
All right,
Bye-bye.
buddy. All right. Thank you.